when person is inside the lift, if lift is moving upward direction and downward direction, what about the reactional force? That is nothing but what is the apparent weight of the object we have to calculate. How we can calculate that one means, see here, first I am writing here lift. Just I draw the diagram lift. This is lift. Now one person is standing inside the lift. One person is standing inside the lift. One person is standing inside the lift. Okay. If lift is rest position, if lift is at rest, if the lift is at rest position, what is the apparent weight? Means, see here, normal force or reactional force, you can call it is normal force or reactional force. Now normal force is acting on a person, it is upward direction, that is reactional force, isn't it? Weight of the object is acting downward direction. Weight of the object is downward direction. Now the lift is not going upward, not moving downward. The lift is not going upward and not moving downward. When lift is at rest position means, see here, upward forces is equal to downward force. It is the balanced force. Upward forces is equal to downward force. So R is equal to, upward force is the R and downward force is the W. Here W is equal to mg. Apparent weight is equal to actual weight. This we can write as a apparent weight. Apparent weight is equal to actual weight. When lift is at rest position, apparent weight is equal to actual weight. Okay. Now, if the lift is moving with a uniform velocity, isn't it? Now, weight of the object is acting downward direction. Reactional force is acting. Reactional force is nothing but a apparent weight, that we are writing as normal force also you can write, no problem. R is equal to N also you can write. This R is nothing but a perpendicular to plane of contact. Isn't it? Okay. Now R is going upward direction, weight is acting downward direction. Okay. Now in this one, resultant force is equal to upward force minus downward force I am writing. If the lift is moving with a uniform velocity upward direction, okay, means uniform velocity. Uniform velocity means, what is the resultant force according to the Newton's second law? Acceleration, R minus W. Here acceleration is equal to 0. Why acceleration is equal to 0 means, the lift is moving with a uniform velocity. When lift is moving with a uniform velocity, acceleration is equal to 0, because acceleration is equal to formula, since A is equal to change in velocity per unit time interval. Initial velocity is V is equal to U minus U, 0. 0 by something is 0, so acceleration is equal to 0. I am writing this 0 means 0 is equal to R minus W, then R equal to W. Again the condition, see here, apparent weight is equal to actual weight. R is equal to W means R is nothing but a apparent weight, W is equal to actual weight. So in the true situation, when lift is at rest position, when lift is moving with a uniform velocity, R is equal to mg. R is equal to mg. R is equal to reactional apparent weight is equal to real weight. Okay. If lift is accelerating upward direction, is case 2. Now case 3. Lift is moving upward. Now person is standing in a lift. Reactional force on a person, it is upward. Weight is acting downward. Now I am writing here acceleration it is upward direction. Acceleration it is upward direction. When it is object is, it is not a uniform velocity, it is going upward direction. Uniform velocity already completed, it is non-uniform velocity. Now when it is accelerated upward direction, how we can write the equation? Resultant force is equal to R minus mg. R minus mg. Why I am writing R minus mg? Why cannot we write mg minus R? Means object is going upward direction. When object is going upward direction means upward force is greater than the downward force. Upward force is greater than downward force. That's why we are writing upward force minus downward force. Upward force minus downward force. And this is MA. MA that is equal to R minus mg. You can write R is equal to mg. If I am taking this side, mg plus ma. Mg plus ma. Here real weight. Here this is actual weight, apparent weight. This is R is nothing but a apparent weight. Mg is the actual weight. But we are adding some numerical value to the actual weight. At that moment your weight is increasing or decreasing? Your weight is increases. See here, R is equal to mg. R is equal to mg plus 0 I am written. Here apparent weight is equal to actual weight. But if I add 2 Newton's force, your apparent weight is increasing or decreasing? Increasing. Some numerical value is added to your actual value. At that moment apparent weight it is increases. See here, this is nothing but a ME is added to your actual weight. At that moment real weight, actual weights, at that moment apparent weight is increases. Apparent weight is increases. So apparent weight increases. Next situation you can write when lift is moving going downward direction. Lift is downward direction. When lift is moving downward direction, at that moment, see here, when person is standing inside, reactional force is upward direction, weight is downward direction, and it is acceleration is downward. When acceleration is downward means downward force is greater than upward force. So resultant force is equal to m1 mg minus r, and here ma is equal to mg minus r. According to the Newton's second law, if resultant is ma, r I am taking this side, ma I am taking that side. So r is equal to mg plus mg minus ma. See here, some numerical value ma is subtracted from your actual weight. At that moment your weight is decreasing or increasing? So your apparent weight is decreases. When lift is moving downward direction, apparent weight is decreases. When lift is going upward direction, your weight is appears to be increases. In these two formulas you have to understand. When lift is going upward direction, your weight is appears to be increases. That formula R is equal to mg plus ma. And when lift is moving downward direction, your weight is appears to be decreases. That formula R is equal to mg minus ma. These equations you can write in terms of the tensional force. Also. How you can write in terms of the tensional force means, see here, tension, about the tensional force I am writing, same equations will become, but sign, the numeric, that what about the letter will be changed, the quantity name. See here, one person is standing inside the lift. Now tensional force is, if it is accelerating upward direction, object is accelerating upward direction, weight of the person is downward, and tensional force is upward. Tensional force in the rope is nothing but a upward direction. it is accelerating upward. So resultant force is equal to upward force minus downward force. Why we have to write? Means object is going upward direction. When object is going upward direction, upward force is greater than the downward force. Upward force is greater than downward force means upward force minus downward force. Upward force minus downward force. Resultant force MA is equal to T minus mg. Then T is equal to mg if taken this side, mg plus ma. So tensional force is increases. Here in these two situation it is going upward direction, isn't it? And when you coming to here, this is upward. What is the formula? What about this? R is nothing but a operant weight. Operant weight is equal to mg plus ma. When tensional force is equal to mg plus ma, both are same. Here it is R is nothing but a according to the person I taken. R I taken it is according to the person. Here T I taken as a lift rope I taken. And when it is lift is moving downward, when lift is moving downward means same formula here also. We can write T is equal to, you can write mg minus ma it is, and m if you take the common, g minus a. For example, someone disconnected the rope wire. When disconnected the rope wire, at that moment, what is the tensional force? Means, see here, when they disconnected the rope means acceleration, it is freely falling body case. The lift is nothing but a freely falling body case. In freely falling body, acceleration is called acceleration due to gravity. In freely falling body case, if lift wire is disconnected, acceleration is called acceleration due to gravity. At that moment, A equal to G means, in this formula if you substitute T equal to M into G minus A equal to G. A equal to G means G minus G, 0. 0 into something, 0. At that moment, tensional force in the rope is equal to 0. And your weight also 0. When lift is going upward direction, operant weight is increases. When lift is moving downward direction, operant weight is decreases. If lift wire is disconnected, your weight is equal to 0. When lift is at rest position, operant weight is equal to actual weight. So here when lift is at rest position, operant weight is equal to actual weight, and when moving with a uniform velocity also, operant weight is equal to actual weight. When it is moving upward direction, weight is increases. When moving downward direction, weight is decreases. When lift wire is disconnected, your weight is equal to tensional force or your weight, both are 0. Connecting bodies. In this one, horizontal surface, blocks are arranged like this. Isn't it? Now, mass of the first block is M1, mass of second block is M2, mass of third block is M3. Now, these three blocks are connected by the two strings. And the force is acting on the first block is F. When they are pulling like this, the three blocks are moving. So, acceleration of the three blocks are same. When they are applied the force along this direction, so the three blocks are accelerating. The three blocks can be accelerated with same acceleration. So first I am considering these three objects as a one system. For your understanding, I am telling you, one room it is a persons are standing here, isn't it? The persons are standing. When I pull this room, just I move that room, the total system of the body, acceleration of the system, it is same. Just I am considering as a one system, not this person acceleration with this person acceleration, not like that. just I am considering as a one system. The total I am considering as a one system. Same here, M1, M2, M3 I am considering as a one system. M1, M2, M3 I am considering as a one system. See, in our body, hand is one object. Hand, if you consider one thing, this hand is another one. So many tissues are there. While I am moving, along with me, all the objects, means my hands and my tissues, all the particles, my shape, my point, everything will be coming with me only. So I am telling here, the total my body has a one system. Total my body has a one system. If I consider, at that moment, acceleration of the each and everything is the same. Acceleration of the all the blocks are same. Hands and shed is nothing but a same. Same here, just I am considering all the blocks are having as a one system. This total, first one, case 1, it is nothing but a one system I am taking. When I am taking one system, according to the Newton's law, it is the frictionless surface. It is the frictionless surface. There is no, we are applying the force along this direction. The blocks are going along this direction, but there is no opposing force. There is no opposing force. So at that moment you can write F is equal to MA. F is equal to MA. Here what is the capital M means total mass of the body. What is the total mass of the body? Total mass of the body. Body means I am taking it is the total system. Total mass of the system is equal to mass of first block plus mass of second block plus mass of third block. So F is equal to M1 plus M2 plus M3 into A. At that moment, acceleration is equal to F divided by M1 plus M2 plus M3. Acceleration A is equal to F divided by M1 plus M2 plus M3. So acceleration of the blocks, that is. Now I want to calculate what is the tensional force. Tensional force between M1 and M2, M2 and M3 I want to calculate. For that one, first I am taking free body diagram of M3. See here, for your understanding, between these two, just I am considering one point. Just I consider one point. Tensional force. See here, I told you very clearly, tensional force is always away from the object. Always away from the object. Just to close these two. When I close these two, means tensional force for this body means away from the body. See here, this is nothing but away from the body. Okay. Now I am closing this one. For this one, tensional force. For this one, tensional force is away from the body. Away from the body means like this. See here, at a particular point, tensional force is equal and opposite. So this is tensional force is T1. This is T1. And for this one, tensional force is T2. Tensional force is the T2. So at one particular point, if you take it, that is nothing but a tensional force is equal and opposite. Now first I want to calculate T2, then after I will calculate T1. Okay. Just to take the M3, free body diagram of M3, it is lying on a one block, a horizontal surface, isn't it? Now this is T2. This is T2. Now tensional force T2 is equal to what you can write. Is there any opposing force? No opposing force. So T2 is equal to M3A. T2 is nothing but a ME. T2 is nothing but a ME. That is ME is nothing but a mass M3. And T2 is equal to what is acceleration? Here what is acceleration means? This is acceleration. Substitute here M3 A is equal to F divided by M1 plus M2 plus M3. So T2 is equal to M3F divided by M1 plus M2 plus M3. Okay. Next, free body diagram of these M2 and M3 as a one system I am considering now. M2 and M3. M2 and M3 I am considering as a one system, isn't it? Now for this one, tensional force is T1. Just forget, when I consider M2 and M3 as a one system, there is no discussion of the T1 here, the tensional force between these two, because here I am considering as a one system. M2 and M3 I am considering as a one system. So these two are as a M2, M3 we have to consider as a one body only. Okay. T1 is equal to, it is nothing but there is no opposing force. So T1 is equal to, according to the Newton's second law, MA. Here MA is nothing but a M2 plus M3 into A. T1 is equal to M1 plus M2, sorry, M2 plus M3 into A. Here what is acceleration? Already we calculated. Acceleration is equal to, acceleration A is equal to F divided by M1 plus M2 plus M3. This one you ought to write here. So at that moment T1 is equal to M2 plus M3 into A is equal to F divided by M1 plus M2 plus M3. For example, M2 only single body, M2 if you taken as a one system, only M2 only single body if you take a free body diagram. See here, this one end is connected to the tensional force is T1 and another end is connected to the tensional force is T2. When you coming to the diagrams here, M2, one side it is T1 tensional force and another side it is tensional force is T2. One side T1 and another side it is T2. So same I have written it is, one side it is T1 tensional force and another side it is tensional force is T2. And it is accelerating along this direction. It is accelerating along this direction. So resultant force is equal to T1 minus T2. T1 minus T2. Like this. Resultant force is M2A is equal to T1 minus T2. Like this also you can write equation. You can write equation like this also. Isn't it? It is connecting bodies. It is connecting bodies horizontal direction. At that moment, what is the acceleration of the system and what is the tensional force acting between the two blocks? What is the tensional force acting between the two blocks, that is T2 and T1? Okay, then after, if the two bodies are contact with each other without tension, without string, these two are contact like this. At that moment, what is the normal force and what is the acceleration of the system? We have to calculate. See here, just again I am taking here three blocks. This is one block and second block, third block. M1 mass, M2 mass, M3. Now force is acting along this direction. At that moment, acceleration is along this. All blocks are moving along this direction. All blocks are moving along this direction. First we have to consider this is a one system. The total has we have to consider as a one system. F is equal to Ma. F is equal to Ma. Here mass is equal to total mass of the system. Mass of the system means mass of the first block plus mass of the second block plus mass of the third block. So F is equal to M1 plus M2 plus M3 into A. M1 plus M2 plus M3 into A. Then acceleration of the system is F divided by M1 plus M2 plus M3. Just I want to compare this equation with the, if the bodies are connected by the string, at that moment acceleration of the block, acceleration of the system A is equal to F divided by M1 plus M2 plus M3. And here also, without connecting of the strings, acceleration is equal to F divided by M1 plus M2 plus M3. These two formulas are same. Okay. Next I want to connect it with, what about the force between M1 and M2? What about the force between M1 and M2? Just write here normal force. I am writing here, see here. Okay, first I am writing about the M3 and M2. Just I am taking it is M3 and M2. Between M3 and M2 I am writing. Now, just now in the previous class I explained normal force. What is the normal force? A force exists when two objects are in contact which is perpendicular to the plane of contact. That is called normal force. Now, the two bodies are connected like this. Normal force acting on the M2 due to M3. That is along this direction. Normal. This is N2 I am writing. Okay. Now normal force acting on the M3. Due to the M2. That is along this direction. That is N2. Equivalent. N2 sir. These two normal forces are equal and opposite forces. These normal forces are equal and opposite forces like this here. M2 and M3 if I am taking. The tensional force is one. For M2 it is acting along this direction. For M3 it is acting along this direction. Here tensional force is equal and opposite. Here tensional force is equal and opposite. Now here normal force. These two bodies are contact like this. The two bodies are contact like this. Normal force is along this direction. Perpendicular to the plane of contact means it will comes like this. That only I given like this. Normal force for this one, it is along this direction, that is equal and opposite. Now I am considering along this direction means N2 is equal to free body diagram of M3. Free body diagram of M3 means normal force is N3, normal force is N2, normal force is N2. So N2 is equal to, we can write M3A. No opposing force here. So N2 is equal to M3A. Here A is equal to, we already calculated, substitute here. N2 is equal to M3 into F divided by M1 plus M2 plus M3. N2 is equal to M3F divided by M1 plus M2 plus M3. Same like that only. If the two blocks are M2 and M3, this is M2 and this is M3, connected with M1. Now I am considering these total as M2 and M3 as a one system. At that moment, normal force acting on this one, it is N1. Normal force acting on this system, it is N1. So this is total one system means N1 is equal to M2 plus M3 into A. N is nothing but a MA. N1 is equal to MA. So A is equal to, already we written M2 plus A is equal to what it is, F divided by M1 plus M2 plus M3. This is normal force, isn't it? So here N1 is T1 is equal to same formula, and N2 is equal to T2 is equal to, where is T2? We calculated T2. These two are, it is nothing but the same formulas. If connecting bodies with a string, without string, with string, without string, we can get the same equation, but that's what it is. The quantity name will be changed. Connecting by the string means we have to use tensional force. If the two bodies are contact, at that moment we have to use normal force. What? The quantity name will be changed, but same formula, isn't it? Same answer also will become. But if you don't, you should not confuse when you are doing the problem. You can remember any formula in this one. Either it is you can remember in terms of the tensional force means T1 you can calculate, that is nothing but a N1 you can place it. That's it. T2 if you means, that is N2. T2 is equal to N2, you can write it. Okay.